Good morning, good morning. Hello. Right now I'm trying to present live for you guys. I'm going to be discussing the method of mirror symmetry, but not necessarily in terms of actual particle physics or actual physics. I'm going to be talking about, this is going to be one of the last lectures I'm going to present. This lecture is going to be about the methodology that I use. I call this one slant rhythms. Basically, in every single bit of conversation, communication, whether it be music, whether it be actual conversations you have with people in front of you in your cherished world, there's always branches that we could take on these conversations. And then some people, they consider that negative. Oh, well, I'm too much ADHD, or I'm thinking too many thoughts. That's okay. Me personally, I encourage people to share with me their slant rhythms, their slant rhymes. What I'm going to try to show for you today is how you can use the method of timetable, keeping track of events in your world, to recognize that there are yet branches, yet paths that you have not delved into. So we're going to begin by making a timetable of this world so I can show you guys the method of returning to your own self and sanity. As you can see, we have to deal with the very real world, the reality of reflections and actual mirror symmetries. And so that's why I drew these square boxes. So then I have a reference point about what you guys can see and can't see. So that's part of the duality of this world. We must recognize that there is a physical reality, that what we're trying to convey, that's quantized. But the reason why it's quantized is because we need to have formalism. What I'm trying to do is trying to show you that the best way to encode your world in your own mind, so you have a continuous reasonable flow or rational thought, is to follow fundamental information theory, or to follow what actually exists in the world. We're not trying to be philosophers. We're not trying to be people who make up definitions. That is not the case. We are trying to define this world rigorously, so we have a concrete path, a concrete schema or structure in which to return to our thoughts rapidly. That is what's necessary when you build an information structure. So I'm going to begin with the timetable. I'm going to show you guys how you can use it actively in your world, in real conversation. I will give you guys a 1 hour opera moment, or a 1 hour event of a human experience. So whether you find this endearing, pleasant, insightful, that's entirely up to you. And I encourage you to make your own formalisms, your own decisions, and your own thoughts during this entire process. If you have to leave at any point, that's okay. This is going to be posted on YouTube, on my channel and such. So if anybody would like to, we'll get to that later. We're going to have an open Q&A section at the last 15 minutes. And that will be at 12 to 12:15. Duality is an illusion. Non-duality means perfection. Going off live description, just joined. Absolutely. I love your pose, and I love your posture in your photo. And so duality is an illusion, indeed. But in terms of duality of the concrete physical reality, we must acknowledge it. It's a fact of life. Duality in terms of choice, in terms of how we choose to live, are all imperfect, for we are infinite, and that's what we're going to actually start drawing formalisms. For we need formalisms in order to return to sanity. So there is one aspect of duality you must accept, or must realize is a part of this world. So because of the timetable, because this exists, there is some flow of time progressing forward, and we all exist together. Okay, we have to now define our time and build upwards, because that's just how I built my coordinate system. So we're now going to go at 11:20 a.m., whatever, it doesn't matter. We're going to go with military time, but you're not going to see the military time occur, because we're not going to reach 1300. So what I'm trying to say is that whatever event we have right here, however long it takes in t, that is one part of it. What am I trying to say with the x-axis? The x-axis in this form doesn't necessarily have as a concrete meaning as it could. because the last time I built a timetable, I invite to join live. Why do you, this random? The ego is a mind unaware of its creative power through perception. Okay, that's a great part of this. So yes, the ego was born when duality was born. Okay, so we have a timetable, and this simply lets us keep track of our mind and of our world. Okay, so we're gonna do something interesting with the timetable. We're gonna, I'll show you as we build our lives, our actual existence in this world. The ego is a mind unaware of its creative power through perception. Okay? Okay. To see good be evil, to see good be evil brings it forth. Seeing perfection brings it forth as well. Oh, verses. Okay. What I'm trying to do right now is I'm trying to break the veil, so to speak. I'm trying to show you this method. However, I am currently in a non-expressive state. I'm currently in a sad and depressed state. So what I'm trying to do is trying to use the method of music so we can show you how these slant conversations, these branching conversations occur in our lives and occur in our world. For it truly is a conversation that can split off, which is fascinating. It's beautiful. And that does match what I have observed with the particle decays. If you have something that has lots of information, it can decay off into different branching paths, which is pretty cool. However, it appears that I am far too depressed, so to speak, in order to even convey these thoughts, and that's part of this world. That's part of the duality. So because I currently have a prior state, and I'm trying to convey a current state, that's preventing me from reaching that target idea. So that's part of this concept that I'm trying to show right here. So our world is built radius r from each other, from ourselves. So from radius r, from away from me, is everything I could possibly do in this world. That's what we're calling psi. Psi is your infinite self. But in reality, it seems like we don't have a truly infinite self, because psi itself is defined with locality, which I'm going to show you real quick why that's a valid formalism. So we're going to say psi is some Fourier series that has some n vectors. It doesn't matter. We're going to say that is all the information that it takes to describe your mind in the moment. That's all your different thoughts put together, your experiences, where I came from. Am I hungry? Am I sad? Am I poor? Do I have free time? Am I stressing? All this stuff. That's what psi in this context could contain. However, all of these aspects of the world technically are still tied to your present moment, radius r. But we're not going to say radius r just as in like my ego in terms of where I am right now. We're going to say radius r in terms of work, function, distance traveled. And that actually works. So we're going to then say that work, because that's actually a form of energy or energy loss, work technically is equal to F times dt, or the integral of F times dt, which is pretty good. We're starting to, this is why I'm telling you, if you know physics, you can start building and understanding the scheme of your world that is consistent and regular. So you can find these paths over and over and over again, which is fascinating, it's beautiful. And the formalism this is a new derivation. I just did, oh dang, okay, that's a new reality I have to deal with. So I'm going to draw a line, a green line, so then I am aware of the challenges of this world. So it's going to be from here to here. So this is going to be the line that is going to be hard to see things. And now that's what we're doing. Okay, it's actually not that bad. Black can be seen through. But you can only know you are limitless by moving beyond limits. Everything must be tested and affirmed. Partially. You are indeed limitless. However, there does exist the second law of thermodynamics. Work isn't force times dt. It's force times... Wait, are you sure? I'm pretty sure it's force times distance. And distance can be defined in terms of time if you derive it for that way. So, it's dx for displacement. Yes, dx. However, that's good. So I like where you're going with this. Yes, it is dx for displacement, but there's an aspect of actually, yes, we must stick to real formalism. Though this is the pain of existence, dx displacement is actual productive work. So this is why formalisms indeed matter in our world. So yes, thank you for that. We have now gained dual discernment. When we are incorrect, when we are imperfect, we only get a partial solution. Though this does happen to work for our flow through time with the timetable, now we are at, and I'm going to try to keep track of the time a little bit more so we can show these events and their causality and their causal chain. 11:26. We have begun. 11:26. Whatever it took, we have finally begun. And however, I might draw this as a triangle because I didn't really give you a full, an accurate description. The emotional flow wasn't there yet. So, we're trying to battle reality. We're trying to battle our own physical existence. So I do agree that Buddhism, when they say life is suffering, this is part of it. If you try to, but it's not just life is suffering and we should accept it. We should accept that, yeah, it does suck. Let's try to find a way so we can stop it from sucking. Death is suffering. Fascinating. I like that you're a little contrarian to the conventional Buddhists. What I'm listening to right now is Time by Pink Floyd. And I want to talk about this real quick because we can get to formalisms, we can get there. And these paths exist, and I must transcend death. I must return to those moments of passion, of love that I had for you guys, for my fellow loved ones. For, like you said earlier, it is those moments that we transcend and we are limitless. But it's not necessarily that we are limitless. It's that we're fighting the second law of thermodynamics always. If I have some target thought, some target idea that I want to convey to you, some R prime in conversation, in order for us to get there, I have to traverse through the Fourier series, through the informational pathway, in a coherent, the way that those kind of Masons say is congruent way. But that doesn't work. That formalism is dumb. It's not congruency. We're not trying to be similar. No. We are trying to be consistent. And that's the formalism of physics. When you try to use slant metaphors, slant rhymes, yes, you can go left, you can go right, and we can get an approximate solution. But it's not an exact solution. It doesn't work for everyone. And that's why it's a lie. That's why it doesn't work. Only if you are part of these groups could you understand their weird metaphors. And that would look like not a direct path, but it would look like a very, very strange line of you need to know these things in order for us to get there to R prime. That is what I'm trying to say, that there are slant metaphors that happen to have correctness, that happen to have correct things of this world. And when you are trying to use slant metaphors in a way to cheat the exact solution, you lose people along the way because you're jumping too much. So in order for us to bring everybody with us to the solution, if you want to bring them in a direct solution, then we have to speak directly. And that is how we transcend even unto death. We're always trying to fight the second law of thermodynamics. So you may be able to come up with an idea. You may be able to come up with R prime, a target direction, a target conversation that you would like to have, that you know can be had. This is your thoughts, your imagination. Anybody can come up with R prime, but can you get there again and again and again? I have an R prime. The R prime that I'm trying to encode for you is, and now let's draw it again. Let's just rebasis our reality. Timetable. It has been 5 minutes. I'm trying to build the world in 5-minute intervals because I study information theory. I study the maximum limits of communication. How much of a thought or an idea in a meaningful manner can I communicate within 5 minutes? And we have reached about approximately 5 minutes. That is when you have to reach the next Fourier, the next this thing. We have to now build the next one. I'm going to now take you in a new direction in R prime, and we're going to do it together. I'm going to erase the timetable, and I'm going to replace it with up here or something. This timetable isn't working. That's not the correct representation, or at least especially for what we could be doing. Okay. I'm going to show you how we begin with some equal plane of reality, some equal plane of everybody together. This center, R equals 0, right here, R equals 0, that is where everybody is equal. That's the statistical average of conversation, of minds, of where people are, so to speak, what they're thinking about. If I want to show you some concept that's R prime, so it's some direction theta, but however, theta doesn't really matter. It sort of does, but we can say theta, we can define theta to be sort of like, in once again, another set of dualities. So theta does exist. It can exist as okay, let me show you. So, based on linear algebra, if we have some set of vectors, and this is part of how we can keep track of ourselves and our world. So like I was telling you earlier, I was feeling kind of depressed, I was feeling kind of negative. So whatever this basis vector is, if you want to find a basis vector, we need to look at the duality of it. So happy, sad, obviously that isn't just what you could feel. There's multiple fundamental basis of our emotional expressions. And I do believe it to be very closely, a very good approximation of the psychological expressions of what they have theorized to be the fundamental emotions. Anxiety, stress, and they do that based on the chemicals that do exist in our brain. So when we use fundamental, real scientific schema, we can identify the basis vectors of our world. And when we do that, we can now define conversations about where we are, about how much, like, when we admit where we are, when we admit what we're feeling, we can then transcend that. That's what I'm trying to show as a lesson for my children. This comes, yes, I care about you guys, the outside public, but this entire formalism came out of love, a deep love for the next generation, so they don't have to repeat the same suffering of confusion, of trying to understand this world the same way I grew up, the same way I tried to do. So, we could call theta, and that's the cool thing. Technically, we don't have just one theta direction, and so that's why when you talk about multi-dimension variables and stuff like that, it does get complicated, and so that's why we could say theta is is this. So if it's positive within this regime, then that's positive. Within this regime of theta, that's negative. But that's just the abstraction of how you choose to define your coordinate system. If you get lost in what do these thoughts mean, then you're killing me. Because now look at what I had to do. In order, because you were the you, but not you the audience, but you the antagonist, you the person that's like, why are you talking about these formalisms? Theta, well, there could be infinitely any emotions. Yes, you're right, of course. That's why this theta formalism is really more of an abstract. This is the theta just represents, yes, the continuum, the spectrum of emotion. Genius, yes, you're a genius, you're Einstein. Good for you. However, I demonstrated to you by having to do all of that. The second law of thermodynamics, you had some criticism R double prime. R double prime because you encoded a thought. You went directly to that thought faster than, that's what's cool about it. We can talk about dimensional analysis now. So this R double prime, we're gonna start talking about dimensions now, about what they really look like. So we're gonna delete the psi formalism because you've seen it enough. I'll give you one more chance to see it. Psi formalism. And as I fight even unto death, I am fighting my own emotions. As much as I love you, and much as this conversation is a continuous one, we have to fight the negativity. My bad, I thought this was Spanish class. Lovely, I love you. Thank you, my brother. Oh no, I did not invite anybody. Oh dang, no, I was just trying to scroll and read this chat. Death is suffering. Life is the way out of suffering. To end suffering is to end death. Yes, I agree. The metaphor of death, it doesn't just have to be you physically died. The metaphor of death means your continuous energy. We can actually define that, and that's what's amazing. All you need in this world is the energy-time relation, the decay life of a particle, and that really is how we exist in this world. We exist as particles with finite consciousness. Not consciousness, but finite expression, time that people will give to us. And that is even unto death. That is death. Because I'm trying to fight death right now. 11:36. I'm trying to keep the joy, the passions that I know I have felt before. That are prime. And you, if you are the negative one, notice how you are really quite negative. So we're going to try to build. Okay, it doesn't matter. We're going to start using linear algebra concepts now. Okay. R double prime. R double prime is that hateful conversation. R double prime will be some projection of R prime. And it may seem to the outside world relative to your R prime, oh, but R double prime is such a short distance. And distance is equal to, in this formalism, dE dt. Distance is equal to the amount of energy and time that you have to exist. So like, in terms of particle physics, the amount of maximum distance a particle can travel before it decays, before it dies, before it disappears and explodes into other decay processes, is defined by this formalism. Delta E delta T. If you owe a lot of energy, you can only exist for a very small amount of time. If you owe relatively little energy, like a neutron, an actual neutron, a UDD particle, a neutron, if you owe a little bit amount of energy, you can exist for a lot longer in an unstable state. The actual time ratio of a neutron is about 600 seconds, I believe. Look it up so you can be more accurate, but it's about either 300 or 600, I forgot. But the crazy thing is, like, that's a lot longer than you would expect. Isn't that interesting? A free particle through this world can last 600 seconds. It's like, what the heck? That's 10 minutes. Interesting. Okay, so we now talked about the concept of projections, the concept of how some ideas can seem like they're more intelligent, like they're more rapid, because they are ignoring the dimensional complexity of what you're trying to project. They are still on the exact plane of the regular continuous spectrum. We can now define not just theta, we can now define phi as the complexity of the idea. And it really does mean phi. And I'm trying to fight even unto death. I'm trying to show you that this is real. 1139, and it happens at slant rhythm, at slant pace, at the same encoding speed of music. As we try to fight this death, this decay process of our emotions, do not try to fight it, but recognize that you are traveling through equal, and it really is, equal emotional expression as the lives lived of your fellow man. And that is how you survive even unto death. That's the meaning of the Christ metaphor. But we're going to get back to this phi in a little bit. I want to read your comments. We're going to get back to phi because I have this. I've done this before. Are you going to believe me now? Or are you going to leave me now? That's okay. I understand that you are human, and I forgive you, and I respect you. And I know you don't have time for this. And I know you think, but those are just thoughts. Those are just our limitless potential, like you have said, blindfolded sight. Oh, of course, you wish you could be limitless, but we're finite, we're real, we exist in this world. You have a fixed trajectory. We're going to talk about that. We're going to get there. However, I am finite, I am alive, and I must exist at some velocity, v, traveling through this world. And that really is t, 1 second per second. What I'm trying to do to you, what I'm trying to show you, is that you don't have to let yourself die. You don't have to give yourself up. You can travel. You can beat the law of thermodynamics. We can reach R prime again. You can. And that's how. Build a formalism. Study your world. Know the duality of where you are. Know how to speak to your fellow man. And you will survive. And you will live. And don't let those people think they're better than you. Because they're like, you didn't say congruent. You didn't say this. Do you know about salt? Do you know about carbon? Because they waste your time. They do. They don't have a structure of this world. They don't know how to communicate to the human being without saying, don't talk to me. I can't tell you these things because you're not part of my club. Those people will kill you. Thus, they are the enemy. Fascinating how we can detect how to spend our time, how to save our world, how to love each other. That's all this was. That's all this ever will be. That's all this ever could be. That's all your life is. Okay. We now have talked about the law of thermodynamics. We now have talked about our trajectory through this world, 1 second per second. I am building for you that basis. I am building for you. We need this. I'm saying we need this. And I'm saying we need this. And I'm saying we need this. And notice, I'm trying to give you an abstract average so you can travel with me in R prime. We now make R prime our basis vector of conversation. You are with me. Can you believe me now? Can you hear it now? Can you see it now? I will give you the average so you can travel R prime with me. And that's how we live. And I do that in the name of you and me so we can live and not die. Okay. Yes, you escape samsara by living. Exactly. You are an actual enlightened one. Indeed. The rainbow body of Tibet is the glorified spiritual body of Jesus. You became an angel by retaining information and the love of everyone around you. Yes, the body and transforming it. Indeed. I don't want to learn math. You're just going to have to know some concepts. So we will need to return back to the projection vector a little bit later. Okay. H, blessings. Invite this. I can pay attention. He jumps around too much. What are you trying to convey? Because it sounds like you're just saying pseudoscience. No, I'm not. I'm not saying pseudoscience. I'm giving you a formalism. This is an information structure. So, like I was saying earlier, an idea is just an abstract point, abstract set of sine and cosine. It's a Fourier transform. It's a Fourier series specifically. An idea, this idea, in order to communicate that, we could define it as some FFT, some Fourier series, and you could define it as whatever, where it exists, and the intensity of those ideas. So yes, you can build a Fourier series. You can build this from an idea. And this is actually how computer science stores information efficiently. And our brains do that every time we speak. I am doing a Fourier series by, like I said, I spoke unto you these concepts. Here, we need this, we need that, we need projection vectors. You need to understand the average mind of where you're coming from. You just enter this live, or so to speak, anybody can just enter this live, and they start at R0. And in order for them to get to R prime, they need to now know whatever this idea was, whatever that idea was, whatever this one was, whatever that one was. And I will take you to R prime. But okay, now let's go back to formalism, because you do need to see it and how it actually looks like. So yes, it will actually look like we need to touch these R vectors. And notice what I just said. This is information. What are these R vectors? They are vectors, and you can define them. Still mathematically. I am surviving even unto death because I love you. And I don't care if you hate me. I don't care if you are trying to go straight to the entropic limit. I don't care if you are trying to violate the second law of thermodynamics and say, the second law of thermodynamics doesn't exist. I'm just better than you. I already reached the answer. No, you're not. You're still going to die. Look at this. So, we have R1, we have R2, we have R3, we have R4, we have R5, we have R6. And I'm saying that you need all of these. And that will equal R prime. Boom. All right, I got to show you all that in purple. Okay, it's black. Who cares? And that will equal R prime. Fascinating. And we survive even unto death. Okay, we need to remove retinol from our existence. Vitamin A retinol causes many problems. Acute retinol, I'm learning, thank you. Head out for errands. Much love, brother. Stay safe out there. Absolutely, I love you. I'm working on a monetary system that bases value on acts of forgiveness. You could define that. That's possible. All right? So if you could connect the dots, you'd be moving at the speed of light. You'd be moving at this, which is T prime, which is the maximum rate of communication, of understanding. So yes, theoretically you would be moving at the speed of light. However, the law of thermodynamics basically says whoever did the work in order for you to travel then at the speed of light, that is the conservation of energy. Don't think that, but I understood this very fast. Of course you did. That means I'm actually teaching correctly. That means I built this formalism off of tons of work, so to speak. And it really back to that formalism that one guy then said, it is not. Work is not. Okay, now we can start building the formalism because it works like a duality, like a mirror. Though I am alive, though I have done this work, you can decipher reality for me as well. And I can decipher reality for you. As long as we protect each other, as long as we're genuinely trying in the pursuit of conversation to reach some R prime. Some okay, I get what you're saying. And I respect it. You're alive in the same way I'm alive. However, I don't want us to waste our lives. Let us decipher R prime together. And that's what we're doing. Giat, of course, Giat. Love the nails. I was speaking in terms of making the mental connections. Yes, indeed. And I'll show you that. So the guy just said earlier that work is not force times time. If it was, then we would be doing plenty of work just by existing. But that is not the case. Not all moments of time are spent correctly or in a meaningful way. That's what the meaning of work is, which is beautiful. Now we have derived what perfection looks like, what actual meaningful existence looks like. And the formalism is, as the man has deciphered, is work is equal to the integral, so the sum of the moments between. Force. Force is the struggle, is that trajectory, is that pushing of ideas through time. We could define those now as, oh, fascinating. We now return to the formalism of the speed of light. Let's see if that is visible. Yes, it is. And I'm trying to show you this next point of musical flow. This is called suave, where we start entering actual flow state. And the music that I'm listening to happens to match the flow of the conversation. I'm trying to show you that your life will never be wasted if you remember the emotional content of your fellow man. Okay, what we're going to do right now, like I said in the other live, we now know that F, the frequency, is equal to the bits stored per hertz. It is. Well, at least in terms of what it actually relates to in real information theory or real information physics. However, what is a wavelength then? If our wavelength doesn't define, like how much information is stored within per hertz, what does that mean? A wavelength in terms of this model, this informational model of propagating information is wavelength is equal to 1 over L, which is equal to 1 over seconds. And what did I say? We live by seconds per second squared. We live by seconds per second squared. You are accelerating through time at 1 second with the acceleration coefficient of seconds squared. What is 1s divided by s squared? Sorry. What is s divided by s squared? That's 1 over s. Pretty cool. Force times time is momentum. Yes. Okay. Now let's get into more formalism. Yes, we can derive spirituality from physics. Let's do so. So we know now that work is a little bit over there. We know that work is dx, which is displacement. So we now know that in order, this idea, R1 is displacement. Delta R, delta R, delta R, delta R. We can calculate the work that it took to generate an idea. We could, but who cares about how much work it took? Who cares? Even though that theoretically should exist, because there are so many authors and so many egotistical human beings that are like, I'm just better than you because I did the work. But they didn't. Well, they technically did because the second law of thermodynamics says that they did. However, they act like they didn't do, whatever. Let's talk about momentum, because that was indeed the next path of particle physics that I was going to study. So let's talk about momentum. Let me catch my breath. I'm going to keep this R prime projection thing. You guys now understand how R prime is built, so we can delete that. We're going to talk about momentum. Momentum is a fascinating area of study that I was just starting to get into in terms of this spirituality or discernment of the world, how you can interpret your world using fundamental information theory. It's not spirituality, it's fundamental information theory. Yes, it is force times time is momentum. That is. Who's? Let me teach you quantum mechanics. All right, go ahead, bro. Go ahead. But mathematically speaking, it's not force times time because then units aren't energy anymore. Oh yeah. That's impulse then. It's impulse. That's impulse. Impulse matters. Impulse could be understood as well. Okay, let's talk about momentum. To go. All right, so now we're in a sad song. That's okay, for it really does relate to what we're going to talk about with momentum. Okay. Like we were saying earlier, or like I was saying earlier, P, which is momentum, P is equal to mv, right? Yeah. Mass times velocity. Okay. What does this mean? So we now know that velocity is some direction, is some travel, some r prime. And velocity really does relate to all your stored states of information. How you're feeling emotionally, all that other stuff, that's what we said. So this is your propagation through time, which is, okay, so now we're going to define r prime in terms of what is this velocity vector in terms of r prime, where you're conversationally going. We're going to use formalism so we can understand our world. So we now say that your state, however, whatever you are in this conversational plane of reality, wherever you are, we're going to say this is your psi, this is your state of information. So that will tell you where I'm feeling, but now this is no longer the conversational average of the world. This is now the emotional, how to define the human being. It doesn't matter, but what matters is this psi of information. That is a vector. What can we do with vectors? So we're now going to just do linear algebra. We're going to just call this psi v, psi vector. Who cares? It's just a vector. So we now have a vector in that direction. Okay, we know that we propagate at time t, 1 t per second. So we now have this over here, and if you normalize it, it should look something like 1 over psi that, I think psi on top. But the point is, you normalize it, and once you normalize it, that now gives you your vector direction, your v. So you normalize whatever state this is, at 1 second per second. We now have v of where you are. What could we define as our mass? We could probably, we wouldn't use mass, we just call this a coefficient. Coefficient of, I don't know, maybe intensity? So once again, we're going to use, we're only going to focus on the way this variable changes. So we now know our momentum is stored as this state, this is P, this is your emotional trajectory. Obviously you can change it, you can influence it, you can change the direction like I was feeling earlier. I was feeling kind of sad, and then I was like, you know what, let's transcend death, and then I did. So the point is, you got to change your states, change the way you're thinking, and over time, you'll be moving at 1 second per second towards a new direction, towards a new momentum. Momentum only helps you keep going straight, because obviously inertia, your object in a straight line will continue in a motion straight line. So it only helps you for so long. So momentum is not reliable for solving problems. It's a flexible variable, which is how momentum is in the world. However, obviously in free space, nothing would change. So if you happen to be in free space, like a very peaceful existence, then maybe your momentum wouldn't change of what you're going to think about. So momentum just tells you that your thoughts are bounded by your current state, your previous state. Oh wow, who would have thought? Pretty cool. Whatever. Okay, let's read some comments. How are you guys going? We're going to get to solving problems. That's this next song, which is pretty cool. The third derivative, impulse. All right. We're going to need to use the timetable again. It's 11:58, so we've done quite a bit in 1 hour. 11:58. Okay, now this requires me transcending even unto death, which happens to be anxiety, fear, and worry. I'm going to tell you what I'm listening to, even though it's quite embarrassing. I have been learning to induce goosebumps for protection. I've noticed if I unbound emotions, the goosebumps can emerge. Fascinating. great. That is a great experience and a great study of your own physical self and existence, which I think is a good idea. Good for you. I'm listening to Revenge, the Minecraft parody. The creeper's trying to steal our stuff again. I'll talk about my encoded metaphors. That's what I wanted to do with this entire lecture. By recognizing that you can encode informational reality. So this song encodes specifically the capture of an enemy, of like, oh dang, there's a negative moment in front of us, and I will show you how to combat an enemy. So use a timetable, for that is how you save yourself. Okay, get inside, don't be tardy, indeed, that's sort of, whatever. Okay, 11:59, don't die. Because I'm trying to show you that yes, we had a negative enemy. Yes, we had an encounter with a villain. Boom, that's going to be our X. That's going to be our target of fixation. However, every single event in this world has quantized information. What does that mean? So, we're now going to try to target our enemy and say, what do I know about this object, this event that's pissing me off, that I don't like? Okay, we're now going to call this psi E for event. And so, dig up diamonds. We're doing it. We're digging up diamonds right now. Okay, so come with me, bro. So, we're going to need to go look at our timetable, 12 again. I'm surviving right now. I'm doing it at 1 minute per minute. At 1 minute per minute, you have tons of opportunities. However, you only have seconds to react. Now, here's what I'm doing in my mind, in my life. So I'm recognizing that there are challenging events. I'm like, okay, I gotta emit a W+. I have to do this. So once again, we're doing our prime, but I'm doing the informational, like the quantized events of like, all right, I gotta send this. I need to send a 1, I need to send a 0, and I gotta do this fast. Because I'm trying to save you. I'm trying to say, dude, we're in a bad moment right now. The bad moment is anxiety, is suffering. We're at 12:15. We're almost at 12:15. And the moment is the enemy, and we're trying to fight that. Okay, so we know that this enemy is trying to deteriorate us. So we say like, okay, it's trying to deteriorate us. What is it trying to do? What else is it trying to do? And then you define the stage, like, okay, so that's an aspect of it. And then you've got to fight it. I need to admit this. W+, so my solution occurs. It nullifies that one. Okay, but I had to do something in return. W-, I had to take something back. And that was time. That was energy. That was effort. But it's okay, as if I can solve this problem. D'. And I did. I did it within the boundary of one song. What time was that? What time was that? 12:01. And we will survive. I went purposely a little bit unhinged, but not really. So in order to solve any event in your world, you have to localize in time. Like, okay, how long will I deal with this? I got to recognize it right now. And then the time aspect helps you calm yourself. It's like, okay, I spent one time in terms of processing this. Well, now I got to do the solution. The next time interval is now going to be fighting the issue. And the last time interval is going to be really beating it down till it's gone. So what did we do? We look at the law of thermodynamics. We're like, okay, I set up the information. I explained that every single object has some information structure. Let's decompose it. Let's think about it. What is it trying to do to us? What can we do to affect it? And then we do it to affect it. It's like, boom, we sent W1. Boom, we sent W2. Let's keep going until we can win. And we did. That's how you solve problems. We're going to keep going until 12:15. I got to actually remind the audience of this one more time, because there are other lives that get a lot more viewers, and it's simply because here's how TikTok works. We're going to talk about algorithms. So TikTok shows my live to more people when likes are happening. So when you get recommended a live is because someone that happens to like the same content as you, who thought that information was valid or in whatever way, it doesn't care. The algorithm just tries to find some duality, some basis vectors, and it says, okay, this person with your likes, with your watch time, with your whatever the heck, you liked it, so now it will recommend that to people with your same characteristics. If you ever think that what I'm talking about in the moment is consistent, is a meaningful thought, is correct, thank you very much for the rose, sir, is meaningful, just tap the like. Just tap the screen. That's it. Do it for till that 98, wherever the heck, and then it forces you to stop. Just do that. Only when you think I'm speaking consistently. Thank you very much, sir. Thank you. Just do that, and then that's how you get more questions and people that actually engage and ask questions. The last 15 minutes, the last 10 minutes are just going to be Q&A session, which is fitting because now we're in once again, another sad, troubling song. So I'll breathe, and if you guys have any questions or any thoughts, let me know. I'm going to try to give you one last conversation that relates to the music, but maybe not this one. We're going to talk about something else. That one's about change and about thinking about with reflection to one's change in their life. We're going to talk about Lose Yourself by Eminem. Really good one. And what is the enemy in Lose Yourself? It's yourself. It's anxiety. It's worry. We're going to do a timetable, and we're going to fight anxiety again. We're going to do it. 12:05 just started. Right as the music just started. Okay. If you had one shot to get anything you ever wanted, would you catch it? Would you let it slip? I'm going to find out. Okay. So, this now means you have a finite amount of time. So we got to think about our coordinate system. Okay, so we have a finite amount of time. So that means we have delta E, delta T in order to accomplish some decay event that is success. In order to lead to success, which we're going to define as R prime because it's some target vector, some target direction that we're trying to get to. Like we said, like we solved, you're going to need to have the average. You're going to need E1, E2, E3, E4, E5, E6, and they must average in that distance, this distance, there. They must average. And that is one aspect of lyricism, of lyrical musicality. When you start giving a moment. And then I said this. That is fascinating. That's really what a musician is giving to you. He's giving you event 1, lyric 1. You're like, ooh, that's pretty good. Lyric 2. And then it came at tempo with respect to lyric 3. So you need to do all of these aspects that combine together give you R prime. That is the emotional conviction, what we're trying to convey. And that is how you convey an idea, at least in terms of trying to have a target trajectory. We've said this before. It came out as a solution again. So we don't need to repeat these words. We don't have to, because you're going to eventually go home and barely know your own daughter. You're barely going to know your own family. How long did it take for us to do this? We were only able to do the 2 minutes. We were only able to do this because of what I had already set up. Therefore, if you did not see what we talked about earlier about how this relates to the law of thermodynamics, about how this has nothing to do with that kind of formalism, congruency, 24-hour day, yada, yada, yada. People that think they're better than you, has nothing to do with that. It really has to do with this informational transcendence, how people think that their projection vector, oh, but I already got here faster than you. No, you didn't. You didn't even do any of the work that it would take to convey this idea correctly. Therefore, I was just playing in the beginning, but the mood all changed because you decided to insult me. You tried to boo me off stage with some R double prime that happened to be in the same normalized vector as mine. But what I'm trying to do for you is trying to show you that the emotions that was stored within the guy before you is exactly equal to you. And you don't have to let him die. You don't have to forgive him. You don't have to forget him. What I'm trying to say is that you will eventually die if you keep doing this to that other damn guy. I'm trying to tell you that it really is a lyrical slant rhyme, and your emotions will never go away, even regardless of how far you are, distance through time. And if you don't think that this is reality, go ahead and kill yourself, because that's all you're doing. You're going to do this to your sons, your children, and your futures. And the future people that are going to have to do the forgiving. And they won't. How can I learn the scientific mathematical terms of prime you speak of? Vector calculus. Vector calculus, and that's it. You technically only need vector calculus for this stuff right here. And it really does happen as a rhyme, as a lyric through time. That's what this is. That's what a stored emotional energy is. I'll ask the AI to teach me. Yes, you could do that for vector calculus, yeah. Ask it about normalizing vectors. How do I normalize some vector r double prime with respect to r prime? What's harder, complex analysis or differential equations? For me, it was differential equations because I it's not the Laplacian, but it's the Laplace transform. No one really explained how it was, like how it was built. My math professor kind of sucked. They were just like, you guys are non-math majors, so we're just gonna, you do it, don't ask about it, just do it. So our math professors at UCLA were very, not egotistical, but they were just like, we get it, you don't really care about math, so we don't care about proofs here. Yeah. So complex analysis is a little bit easier, but not actual math complex analysis. That gets way harder. Complex analysis in terms of quantum mechanics is, I was a math major at UCLA. Oh my God, no wonder you're a genius. Okay. The only part that complex analysis matters in terms of this ideology or this knowledge really is related, and once again, back to music. We're going to talk about the real component and then the non-real component. So complex analysis that we did in quantum mechanics is psi complex multiplied by psi real, and then dt dx, whatever. So that's pretty much it. You just do this, and then you have some normalizing factor in front. So it's actually, no. Normalizing is a regular, so you do n over a. It's a little weird, because the amplitude is just what you're going to get when these multiply with each other. So the amplitude, it's like a n over a. N is your normalizing factor, which makes sense why it's a normalizing factor, because technically we're doing 1 over the amplitude that you would get when you multiply these two, multiplied by n, the normalizing factor. And if you do that, that gives you your expectation value of x, in this case, because we had time, of t. So expectation value roughly corresponds to average. So if our expectation value for now, we're not going to say y, we're going to say x, we're going to say y, just for some height above 0. If our expectation value was, say, 2, for whatever reason, that means on average, this waveform, whatever it is, will be 2. So expectation value in terms of what we did is just like you evaluate the complex part as it relates to the real part, and that tells you what your average is, which is pretty cool. The difference is the psi and the real are typically very complex and difficult to do in real functions, because you're not just doing a regular Gaussian or a regular polynomial equation, you're doing matrix. So you're doing e to the negative, and then you actually put a matrix up here. It's like the Pauli matrices. And then for some of them, in terms of Fermi's golden rule, like once again, you don't want to write things if you don't have actual dedicated notes for them, because like my physics professor said, you don't integrate in public, and you don't derive unless you've done that derivation the day of or the week of. So roughly, Fermi's golden rule is going to look like e to the minus I, which is the imaginary component, times e to the minus psi. So like the minus just means that it's 1 over e, so it's like a decay function pretty much, and then that lets you normalize it. So as you know, when you multiply e's, you're actually adding them together. So that's part of how the trick works. It's pretty cool. So I really like that when you understand how to build functions, how to read them left to right, you're like, oh, well, in reality, because we have two of these multiplying e's, that's really going to be minus m plus the product. So basically, this is how you can add probabilities together. So because we know these waves decay over time, they're going to have a minus e component. That's always going to be there. However, then you basically start realizing, like, okay, we have matrix 1 plus the solution of matrix 2, and then it sort of becomes like that. You can read the functions left to right. It's fun to do, but I'm out of practice of doing it. I haven't had any need to do it. So I instead of going here, I touched grass, and I'm like, I went here. So that's part of the song right now, Lost. You know, it's like, I'll always remember you, my brother, my friends in the military specifically. I love them, man, but they don't know how to do this stuff. At least it doesn't matter to them. All those numbers and you still can't find pants that fit you, Lamau. I like this style though. Like, it's like almost like bell bottoms kind of, you know? I like looser pants. I don't like them when they're like you know, super like that and stuff. So it's hard to find. I mean, I like this style the most. And we could talk about one more emotional event, which I guess I will. We're gonna see what I can do with rhymes and verses. We're gonna talk about Gangsta's Paradise. It's 12:15, so as soon as the song is over, we're gonna cut it out. So that's entirely related to what you just said. The pants and math are both great. Thanks for sharing. Thank you very much. There's something on your nails, bro. No. This one fell off. The other ones, so I've already explained it in the previous live. A coworker had a niece-in-law that she wanted to work on her first male client. So I was like, okay, fine, I don't care. I came up with this design though. So she's like, oh, well, what would a guy come up with? She thought I was gonna go with like grunge or whatever the heck. Dude, that's basic. So I went with this design. Let me show you an actual full set. So blue, white, gold, pretty cool. So yeah. Do or die, I'm living life, whatever you say, I really don't care. Well, at least I shouldn't care, because I know the way things are gonna go. You're just gonna like either ignore me and then go back to your friends and family, your loved ones. You're gonna say like, oh, I know more than them, I know R prime, even though they're trying to convey our double prime, which their direction. And so because you're lazy, you're gonna be like, oh, well, I already have the normalized direction, so I know enough. Like, but you didn't really explain anything, which is fascinating. So you can use formalism to sort of be like where people are informationally, and then you're basically going to be like, well, either listen to me, or I'm not saying listen to me out of like I'm forcing you. I'm basically saying I'm reminding you that either listen to what's in front of you or recognize that you're killing yourself, like you're wasting your own life. So go find something if you think it's more entertaining elsewhere. It's a fact of our world. How can they reach me if they don't understand me? I guess they can't. I guess they won't. I guess they front. That's how you know your life is broke. So I'm trying to tell you that your life is always in front of you. You always have the opportunity via slant rhyme, slant rhythm to basically reflect and be like, and unfortunately I didn't even get to slant rhyme. I was spending this whole lecture just explaining, once again, a little bit more of the depth of emotional expression. We're gonna need to get to slant rhyme about how it works a little more later. This is more about slant expression, how you can use the expression of other people to recognize that where you are is a valid place of existence, and you can derive a new R prime that's useful. But it's still technically related. It's still part of Gangsta's Paradise. So if you ever wanted to go back to there again to share it with other people, listen to Gangsta's Paradise again and you'll get there. What you know about scalar fields? They're like noise fields, and I do use them in terms of, so the way you use a scalar field in terms of decay and probability, I'll show you real quick. The way you use a scalar field that's actually a valid way, we're going to say this is noise. That's noise. So 0th order. So scalar field means background noise. It means nothing useful was there. It basically means we started alive where there's just nothing. That's a scalar field. It's full of potential. You got to do stuff. You got to inject particles into there. You got to do work. You have to now build some basis of particles. You now have to make a proton. You have to define what a proton is. You have to make a moment. And then you actually start doing nuclear physics without realizing it. Okay, we built a proton, we built a neutron, and then they come together. And so now we have a proton, a neutron, and basically what you're doing informationally is you're actually building from nothing. You're injecting a moment with W plus or whatever it takes for you to build the moment. If you look at what already exists around you, what's stable around you, you're looking at information that already exists. Whenever you look at the 0th order field, you're sort of looking at, okay, this is nothing. Relative to something, so this is like 1st order. This is stuff that already exists. Anything above that, it has decay processes. But also, anything above just regular proton, neutron, and electrons, and hydrogen and helium, in terms of their quark content, whatever, I spelled that wrong, you start getting into chemistry, which I haven't done. I've only gotten to helium in terms of quark content, but I haven't done any studies into the quark content of lithium and above. The quark content for helium is really weird. Last I checked, it was like 4 ups and like 2 downs, but like not the regular kinds of up and downs. It has this weird form where you do double up, so it has 4 of these, and it has 4 of these. It's fascinating stuff. When I last was working on trying to solve helium from a fusion quark standpoint. So once again, don't derive from memory, don't integrate in public. So you don't derive from memory, and you don't integrate if you haven't integrated that solution. So this is what I have done. So this is how you use a 0 order field. You recognize what's noise, you recognize what's already there, and then the point is about what's noise is that if you ever build something that decays back to nothing, like a D particle, like a kaon, which is equal to U, S bar, and stuff like that, if you make these, this is actually a charged particle, if you make these will decay back down to nothing. They'll emit back down to basically 0. That's how you use a scalar field in terms of information decomposition, about looking at what information patterns are in your world or in your solution, in your problem space. All right. Can you share a bit about your educational background? Sure. Let's just end the live on that. I have a degree in physics. Got it from UCLA. I studied particle physics at one of the last classes of my coursework. That's when I discovered this decomposition method of the standard model. I showed it to my professors. He's like, okay, it happens to work. It happens to have hypercharge and stuff, but there must be literature out there on it, and there isn't. My model successfully predicted pentaquarks and tetraquarks, but it also predicted the decay modes of pentaquarks. So like I said, hey, a charm quark has an up, an anti-down, and a regular strange inside it. And they're like, no way. And then if you look at the what actually decays from charmed particles, it has those products. So it's pretty cool. What I'm currently doing is just working as an electrical engineer. I'm trying to solve the helicity. In case we'll talk, well, I guess we'll talk formalism so people can whatever. So I'm trying to solve the helicity of the omega particle because the helicity is unknown, unstated. It's the SSS particle. So it's pretty cool. It has one full negative charge. So far I've shown that the reason why the helicity is unknown is because the strange thing of it is that it pulls from the scalar field, so to speak. It pulls from virtual particles. It makes virtual particles real. What I mean by that is that I'll show you real quick what I've done. So the SSS particle has two decay modes. One where it turns into USS and anti-US, and this is a regular kaon, I think, or it might be K minus, doesn't matter. So it looks like it's a K minus because that's a minus 2/3 charge, and that's a minus 1/3 charge. So that clearly must be a minus 1 charge. So it must be the minus kaon. So this is the primary decay mode. We know this occurs. The other decay mode that happens for this particle is it has a DSS and a D bar S, which is fascinating. This is now K, okay, this is K0 and that's K minus. So, but they don't know why these happen if it just, like, you get me? The strangeness is preserved. There was no other stuff there, and these particles appeared. These particles appeared. We didn't do any work, so to speak. The S just goes there. These two just go there. These two just go there. Where did we get the D? Where did we get the up? That is why the helicity of the omega particle is unknown. They're like, how did we get those? Why did we get those? As far as I have shown, through using my model, you pull it from virtual particles. You're allowed to use virtual particles because virtual particles always exist. The difference is, oftentimes, they do nothing to your reaction. Often. However, in this reaction, this one just pulls it and it makes it real. This one, however, puts the kaon, or which one? It puts one of these into an owed energy state. And it's in my iPad, but I can't open it up or else the live will shut down. So this one is confirmed to be 100% real. This one is a very short-lived transition state, which makes sense. Like I said, it's an owed energy state, these Ds. The ups just makes a virtual particle real. This one is an owed energy state. This one cannot exist for any period of time longer than the formalism of dE dt h bar over 2. Well, that's equal to less than or greater than. The reason you just have to remember like which one's which, it's not hard to remember, is that this is always going to be the smallest, or practically the smallest possible thing in reality. Therefore, it's greater than or equal to h bar over 2. So that's what I do. Could you find the direct implications of predicted decay? That could help get you published. Oh, we already know. The direct implications of predicted decay using information theory just means that you can now predict the likelihood of an event occurring in reality. So I explained it in my previous live. You can watch it on YouTube. Go to the very end, I think the last 20 minutes, and I explained how you can use the S particle in ground warfare. I explained how you could use this in terms of predicting a tank's next course of action. You can surprisingly enough, because when I did this in my engineering notebook, which I'm going to keep secret, because I do believe it is a valid security concern, because it's a new piece of technology. I'm pretty sure it already exists, but I'm just doing it in a new way. So pretty much the S particle, because it represents an up and an okay. S is equal to U bar and D bar. S bar is equal to U and D. Charm is equal to U, D bar, and S. Charm bar is equal to U bar, D, and S bar. Pretty cool stuff. Haha, likely, aka a Facebook like. Well, unfortunately, we got a lot more people now, so I kind of feel obligated to go again, or at least to try to do another 15 minutes. But that's kind of long. Well, how much longer would I have to go for if I wanted to complete the second hour? 45 more minutes. No, 45 more minutes. Would you guys like to see another 45-minute section? We can talk about whatever you guys want to talk about. You're on some good points. You're on some good topics. Trying to be perfect. I guess I could do another emotional flow because we didn't even get to the second part of it, which I was going to try to say was slant rhythm, slant metaphors, where you can continue a conversation. This is no longer related to particle physics or particle decomposition. This is used for decay reaction, decay prediction, and fundamental like how to predict what is the likelihood of events or what are the possible events from this information pattern. Most stuff informationally can be described linearly and simply. When you have a more complex system with more degrees of freedom, more choices, you use the heavier particles in terms of the standard model, which is pretty cool. Okay, I'm gonna keep going because we're gonna try, I guess. We're gonna try for the second hour because, like I said before, I can do this in terms of opera hourly moments, and I can also do this in other moments. However, I am feeling a fear, all of a sudden, I'm feeling a fear that TikTok will shut down the live if I talk about a little bit more cool stuff. So I'm going to shut this down so we have this information preserved, and we're going to talk about cool stuff in like a minute. I'm going to go get some water, drink some water. I'll be back at okay, let me check the time. 12:40, MT. So mountain time. So 12:40, 9 minutes. We'll have a lecture break before the next lecture. Take care. Your live is interesting. Come back in 10 minutes or 9 minutes. I'm shutting this down just so I can make sure this is saved.